What's up, everybody? I want to thank you guys for checking this video out. I also want to apologize for the delay in getting this video up. Unfortunately, we've had some health issues with a close family member of mine, so I postponed doing any videos for almost 2 weeks. Good news is, things are starting to look up a little bit, so I'm back on schedule. I'll be doing at least one Anvil Crawler Weathercast video per week, maybe more depending on what's going on, but at least one video per week. So tonight's video, I'm going to discuss what I think we can expect across Kentucky and the Ohio Valley for the coming week. Temperature, we're going to think storms, maybe a couple strong, and I think we might answer a flurry or two. So we'll get into all that. Then we'll also discuss this huge cold blast that everyone's talking about. I know the model graphics all over the internet for the CFS model 500 hours out and the GFS 240 hours out. So we'll get into that a little bit too. As we look at satellite imagery across the region right now, there's not a whole lot going on. We had a weak cold front pass through today. It led to some scattered showers across the region. That's all exited out from west to east and the eastern seaboard. There's a little bit of remnant cloud cover associated with the frontal passage aloft, but that's going to clear out from west to east as well, and it should be a relatively calm night. Now, as we look upstream, we've got a surface high developing in the wake of the low that just moved through, and that's going to really few days. That surface high pressure and dry air making its way, and that should lead to pretty clear skies, pretty calm weather, and then a gradual warming trend as the high slides east. I think tomorrow will probably top out in the 40s, maybe some low 50s, with lows in the 30s overnight. Saturday, I think we'll hit the 50s. Sunday, the trend continues with highs in the upper 50s, lows in the 30s. I think clear skies are going to lead to some pretty sufficient cooling overnight, but I think Sunday the trend continues. We hit the upper 50s. Monday, I think the warm advection regime continues even farther and strengthens ahead of the next system that's going to come through, and I think we hit the 60s. And then might be a few scattered showers on Monday. It's going to be there's going to be a weak shortwave we're going to look at. There's going to be a weak shortwave trough that's supposed to slide through, and I think we'll see a lot of due to the warm air advection, I think we'll see a lot of what's called isentropic ascent, or overrunning, with air riding up over colder air. I think we'll see some scattered showers. It looks like the best rain chances are going to be Tuesday. We'll dive into all that in a second. I want to look at a couple features on water vapor imagery, though. There's a couple features on here that have a big impact on how things play out for the next the next couple weeks. First, you see our trough that's sliding off to the east, completely out of the region, with a vortex associated with it, and dry air working into the region. Of course, you got a surface high in the wake of that trough, and pretty much flat zonal flow across the rest of the country. Zonal flow just means primarily west to east. The features that I really want to point out are this cutoff low just southwest of California, and this broad area, this broad ridge to the west of that. I think these are going to have a big deal, particularly this ridge. I think that's going to have a lot to do with how things play out. So where that ridge sets up at, you're going to drive where the polar front jet, where the jet stream sets up. It's going to have a couple big effects. One, it's going to determine the extent of cold air working its way down into the country. The cold air is going to get here. I'm highly confident in that. Everybody I've talked to is confident. There's a consensus there. It's going to be, where does the cold air get to? And then also, of the polar front jet is going to determine of the disturbances that ride along the jet stream. So where low pressure sits along the polar front jet is going to determine where rain chances are, where snow chances are. It's going to really drive a lot of it. So where this high pressure is going to be critical over the coming days and how things play out. I believe this is going to, and we'll look at this in the models here shortly, but the consensus seems to be that this low will develop into an open wave, track across the central plains, and might bring a few rain showers to the region come Monday, but we'll look at that as we dive into the models. All in all, before we look at the model data, just based on the observations we've already got, high pressure is going to build in starting now through the weekend. It's going to be calm. We're going to have a slight warm, or not really a slight, we're going to have a gradual warming trend across Kentucky and the Ohio Valley. And then things are really going to start to change after the weekend. So first, this is just the NAM model right here. Precipitation type, we're going to see what it's suggesting as we move forward through the weekend. And see if it's in line with what we're anticipating. So there's our surface high pressure building in and strengthening. Moving to keep things pretty quiet. With the exception of the West United States, everything's pretty calm. Let's try to generate some weak shower activity with a cutoff low as it comes through the Four Corners region, but nothing too significant yet. And then you start to see the high pressure sliding eastward as we get in. Now this is Saturday night into Sunday morning, suggesting some snow showers up in the northeast U.S., but nothing too significant yet. Still high pressure dominating the region. And now the pressure gradient across the central United States starts to tighten up as this next Big Bear Clinic wave starts to slide through the region, with snow up in the northwest, which isn't unusual at all. And then you start to see some mixed precip developing along the frontal zone with this low pressure system here in the northern U.S. Pretty tight pressure gradient. That's going to lead to really gusty winds out ahead of this thing, which is part of that warm advection regime that I was talking about. That's really going to help surge the warmer air and moist air northward. Some of the model data a few days ago that I was looking at suggesting the possibility for thunderstorms come Tuesday, my biggest doubt was what was the moisture return going to look like. I really had doubts that we would get the moisture return and the theta E return that we would need to really fuel anything else other than some scattered showers. But the models have been converging, at least somewhat, in regards to the moisture return flow. So it looks like the moisture is going to be there. Doesn't look like the instability is going to be much, but at least looks like moisture is going to be there. You can already see that system really tightening up. It's a broad low pressure system, but it's a fairly deep low pressure system. So that's the NAM cycle this time. Right now it looks like all the snow, with the exception of the western United States, it looks like it's going to be mostly rain for the northern Midwest, and it's trying to show that the snow is going to stay into Canada, in the Great Lakes region. It's going to stay north of there and into Canada. That's going to have to be watched though, because it's a really sharp line, and the model looks like it's got the precip changing over basically right at the 540 line. The 540 line's a good indicator for precip type, but it's not always dead on, so that'll have to be watched. But locally, not a whole lot changes here through the NAM cycle. Not a whole lot changes in Kentucky, with the exception of the warming trend, and winds will start to increase as this low pressure gets close. Next, we'll go ahead and pull up the GFS and go out a little bit farther and kind of see what it's suggesting. So the NAM really supports the forecast as I laid it out already, just based on the observations we've got. The GFS will give us the ability to go out a little bit farther than maybe we can anticipate. We'll go ahead and go with the CONUS view. We're looking at the GFS model, and we'll look at some more of the dynamic stuff here in a second. Now we're just going to look at precip type, precip rate, and just compare it with what we just looked at with the NAM. So similar deal, surface high pressure builds in back behind the system that just moved through and pretty much becomes established across the Ohio Valley. Got it moving a little. It's a little bit more progressive in its eastward move, but that's really not going to change a whole lot, except maybe the warm advection might pick up a little bit sooner. but it's not really affecting a whole lot. It's still relatively consistent with the pattern we can expect over the weekend. Then it begins to build again, and you see the pressure gradient tighten up across the Midwest in response to the deepening cyclogenesis, the deepening surface low across the northern U.S. and central U.S. And it also develops rain showers, maybe some snow showers along the warm front, and then the occluded front zone, and of course in the elevated areas on the back side of the system. It's already showing 998 millibars, and now you've got the cold front. So we'll look at the I'll sketch this in real quick just for visual reference purposes. There we go. So at 06 Tuesday, so this would be midnight Monday night, it's got the cold front back like that. So that's 06Z tonight, Monday night. Step it forward a little bit. So it's got the cold front moving through Tuesday afternoon. It starts skirting through western Kentucky by Tuesday morning. It slides through central Kentucky by Tuesday afternoon. And this is when I'm thinking we might see a few stronger storms. Severe storms, not necessarily, just owed to the fact that it's going to be weak. But I think that this cold front is going to, I think it could generate some stronger storms. The moisture advection is going to be a little bit stronger than I initially expected. So I think that's going to help. In some regards, it's at least going to provide some fuel for the storms. But again, instability doesn't look to be too strong at all. So I don't think we're looking at much of a severe threat. And then, even if we were, with the way the wind fields are lining up, it's going to be forced descent along the cold front. It looks like a pretty progressive cold front. So it would be more of a linear system that moves through relatively quickly. But again, I don't see much of a severe threat. But as you can see, especially according to the GFS, definitely a heavy rain threat. And then it's got the cold front pretty much completely out of the region by 06Z Wednesday, which would be midnight Tuesday night. So 24 hours from pretty much northwest Illinois all the way through Kentucky. But here's the interesting thing. It's got some snow showers trying to develop. It's trying to spit out some snow showers on the back side. On the back side of the cold front. It's not necessarily out of the question. You can see pretty strong cold air advection back behind the front. I'll actually show it for assessing cold air advection. Now there are specific generated tools you can use, analysis charts you can use for thermal advection. But I'll show you the box technique real quick, which is overall it's a pretty cool technique that I like. So we've got our thickness contours here, and then you've got your isobars, your pressure contours here. Where the thickness contours and the pressure contours cross, any areas where they make boxes, I'll draw it out here. You see they cross each other like that. I'm not going to draw out every box, I'll just show you the rough idea. So you see where they cross there. Now if you fill these in, and you see that they make these little imaginary boxes. These little imaginary boxes are a quick way you can assess the strength of the thermal advection. The smaller the box, the stronger the temperature advection. So as you can see, there's, at least according to this model, and I've looked at some other models too, and the ensembles, so this isn't totally unrealistic. The model converge somewhat. According to this model, it's showing really strong temperature advection back behind the front. So if it manages to move through and there's still enough ascent and enough saturated air, I don't think snow flurries are out of the question. I don't think we'll see anything. It's not going to be anything that's going to be terribly notable, but could see a couple snow. And now, just for fun, we'll go ahead and run this model out a little bit farther. But at this range, I mean, we're 132 hours out already. So, I mean, it's one model run, 140 hours out. You can only put so much weight on that. But it continues with the trend, with a few snow showers moving out. I'm not entirely convinced that we won't see a few snow showers Wednesday as this system moves out. Again, it's not going to be anything terribly, it's not like we're going to be looking at significant measurable snowfall. Even if we did see some measurable snowfall in, say, eastern Kentucky, I don't think it would be more than 1/4 of an inch, if that. But then here's where things really get interesting. And this isn't anything that I'm really weighing out. I want to wait until more data comes in to really address, a whole week and a half out. But this is really starting to focus on is the series of disturbances that are anticipated to revolve around a deep low that's going to set up across the central U.S., the northern and central U.S. So there's going to be a big broad area, a big dip in the jet stream across the northern and central U.S., and then there's supposed to be a series of disturbances of waves pivoting around that broad dip in the jet stream. Each one of those disturbances could bring a chance for snow. Now, what I will say is the temperatures are going to be cold enough for snowfall. That's highly likely. I don't really doubt that at all. The part that I doubt, and I don't want to put too much faith in 500 hours out on a particular forecast model, is the timing and location of snowfall. If a model's saying we're looking at a snowstorm on the 16th, one is showing like 17 inches of snow across the entire northern 2/3 of the U.S. on like the 16th, I'm not going to put a whole lot of weight into that just yet. But what I will say is that there will probably be a series of disturbances pivoting around the dip in the jet stream, and each one of those disturbances has a chance to bring some snowfall. The temperatures are going to be there. It's going to be deep, cold air, so it's entirely possible to see snow. I'm just not willing to jump all over this huge snowstorm for 2.5 weeks from now. That's all I'm saying. And at this point, we're in the voodoo range. Here's what I was talking about. This is basically the voodoo range for the forecast models. So this is the stuff I was talking about, where you just see this massive manifestation of snow and ice across almost the entire U.S. That's the part I have my doubts about. And a lot of times, these models, the way they work, they're prone to errors, first of all, because it's very complex equations that they're solving. So it's pretty simple. They do relatively well in the short range, and they do well with a lot of large-scale processes. But as you extend farther out in time, any error that model might have, every single error will multiply on itself time and time again every step you take with a model. So that's why when you're looking 348 hours out on the GFS, it's hard to put a whole lot of faith in that, because you can't really trust that it's solved everything perfectly. So it takes, a rain shower to pop up in one place, and it'll manifest that into a huge snowstorm down the road. So that's all I'm saying, is just be cautious when you see these 400-hour model graphics posted. Just be cautious. Understand it's going to get cold. There are going to be disturbances that might bring some snowfall. But I'm not ready to say the entire U.S. is going to get hit by a snow and ice storm 3 weeks from now. We'll back it up a little bit. I've got some more about that here shortly, but I want to back it up just to some of the data, what we could be looking at come Tuesday. So, I'd mentioned that I do think the moisture advection is going to be a little bit better than maybe initially anticipated. So 2 meter lifted index. Alright, so now that we got that loaded up, we'll go ahead and run this thing out. And initially you'll see the effect, move that out of the way. You'll see the effects of the surface high pressure building in that we've already looked at. And it kind of suppresses that moisture southward. Some advection across the central plains along the western periphery. And this was initially progged to be a lot weaker. That initial surge of moisture northward, initially, over the past few days, was progged to be a little bit weaker than it is. So if it surges northward like that, that's kind of a jump start, and that could really help things out as far as if we have enough moisture. So again, you see it used to surge. You're starting to see 60 plus dew points across eastern Texas into eastern Oklahoma. So the moisture axis. I do want to point out this is just the surface 2 meter dew point. So this doesn't address the depth of the moisture, which I've stated time and time again is critical. The depth of the moisture is really important. How deep the moisture exists throughout the boundary layer is important. 70 dew point at the surface in one place can yield an entirely different result than a 70 dew point in another place, depending on how deep that moisture exists throughout the boundary layer. But it's a good place to start. Typically, I'll look at the surface dew points, and then I'll move on up to the 925 chart and the 850 chart, and I'll look at that, and then you couple that with, excuse me, then you couple that with your SKU-T charts, and just to, assess the depth of the moisture the best you can. So as we get into Tuesday, this is ahead now. So there's our cold front, pretty much right back here along this moisture gradient. So now we're getting into Tuesday, where we're expecting the cold front to move through locally. So as the cold front moves through, it's showing pretty much 50 dew points across, 55 dew points across most of the Ohio Valley. With the moisture axis, which is always what really intrigues me, and you can see the moisture is even aiding a little bit of destabilization across parts of Louisiana up into Arkansas. It's not terribly strong. Lifted index -2 isn't necessarily, it's not the strongest you're going to see, but it's enough to support some thunderstorms. If the moisture advection overachieves what the model is showing, then I would think storm potential would be greater across the Ohio Valley, especially up into Kentucky. Obviously, if it underachieves, I think it's going to be, and mainly that's because a lot of potential instability. A lot of the destabilization we're going to see is going to result from strong moisture advection and theta E advection. And of course, you see the cold front pass, and we won't step it any. There's no point going any farther than that. But another thing is you're going to have the cold front, the strongest forcing for ascent, and then the more favorable dynamics, or the more favorable kinematic field, your wind fields, are going to be up here to the north and through, and then the deepest moisture axis is a little bit south, so it's kind of, it's not quite co-located. If you get an area where those things overlap, where you get the greatest descent co-located with the moisture axis and the more favorable wind shear, you could generate enough buoyancy maybe to get some severe wind gust surface, something to that regard. But all in all, again, I've stated, I think we're just looking at the potential for maybe a few, for heavy rain and maybe a few strong thunderstorms, and then the cold front will move out. And at that point, it's going to be downhill temperatures from there. We'll go ahead and look at some of the convective stuff while we're on here. Most unstable cape. And for those of you that are aware, I know a lot of people know, but for those of you that are aware, this is just the cape that derived from lifting the most unstable parcel throughout the sounding. So that you just find the most unstable parcel, and this is the cape that parcel is progged to generate. And CAPE, of course, again, this is just another thing, but for people who are unaware, CAPE is just convective available potential energy. So it's related. It's a good parameter for assessing instability in the atmosphere. So it's tied in pretty close with. You can use it to try to assess updraft strength. There's an equation you can use to assess updraft strength, but it's tied in pretty close. It's got a lot to do with your buoyancy. You're assessing the buoyancy of a parcel of air. How rapidly will that parcel ascend? If something triggers it to ascend, that's kind of the kicker to it. You can have extremely high CAPE values, but it's only potential energy. It doesn't become kinetic energy until something happens to trigger it, whether that's a front or you get some kind of a shortwave trough moves through, some strong diurnal heating, something to get it moving into the vertical, then it becomes kinetic energy. So step this through, get it up to Tuesday, and see what it looks like out ahead of our cold front. So it is showing some instability out ahead of it. It's going to be in the overnight hours, but that would be associated with a strong low-level jet, a nocturnal low-level jet, surging that moisture northward, northeastward really, but it's going to be a strong low-level jet surging some moisture northward and helping to destabilize things in the overnight if this in fact verifies. That would be just kind of what the model's picking up on, generating these CAPE values, which they're still not terribly high. I mean, 300 joules per kilogram, it's not that high. I mean, it's really low CAPE values. It's marginal instability. It's kind of dislocated from where the more fast descent is going to be. 50 knots, 50 plus knots of so that would be support marginal severe storms if that did in fact verify. And as it moves through the local area come Tuesday, it's not really showing a whole lot. Lid strength index is another parameter I'm a big fan of. It allows you to assess the strength of the cap. A good first guess for the strength of the inversion. Obviously, you want to use it to really assess the cap, but a good first step is your 700 millibar temperatures. You look at those relative to the environment, and that's a good first step. But lid strength index, generally speaking, and they've actually done a fantastic the College of DuPage site. I've made a point to use all browser-based data for this. But for these videos, I have a few software programs that I run specifically all the time for my weather forecast. But I thought it would be more beneficial for these videos to try to use browser data that anybody can use anytime. And this is the College of DuPage site. They got a really fantastic site, and I love it. And it's one of the only places I've ever found the lid strength index. So that's definitely a check in that box as well. And they've done a great job with their color table. Pretty much one are going to be favorable for, if storms develop, it would be favorable for them to be able to break the cap. Cool colors show a cap that's too strong to be broken, basically. And there's no such thing as a rigid parameter in severe storm forecasting or any kind of forecasting. It's all rules of thumb, and they're all loosely applied, and there's always exceptions. But, you know, it's always good to look at these things and kind of combine them. So let's see what it's showing. Just out of curiosity. Step through obvious pressure and subsidence in the region. Not expecting a lot. Monday, any showers we see Monday, I believe, will be tied into, it's called isentropic ascent or isentropic ascent. And basically, it's just overrunning. I'd kind of mentioned it before, where you get warm air that's just overrunning colder air. They have isentropic charts on here. We'll discuss another time. But it basically has to do with a parcel of air doesn't necessarily move in a horizontal fashion, but it clings to what's called its theta surface, which is its potential temperature. So it clings to its theta surface, and isentropic charts allow you to assess those fields. So you can assess areas for ascent. It doesn't really work that well in convective regimes or really weak wind flow regimes, but in the wintertime, isentropic charts do come in pretty handy with stratiform precipitation events. I think that's what we're going to be looking at. Tuesday is when it's going to be the stronger cover, and we get forced descent along the frontal boundary. So, again, as I said, for Tuesday, I'm not really expecting a whole lot in the way of severe weather as much as just thunderstorms. Well, pretty much heavy rain, maybe, with a few rumbles of thunder and a chance for maybe a strong storm or two. But it's worth keeping an eye on. You know, all it takes is things to underachieve, and everything's completely different. So, I'll show you guys one more parameter, and then we'll do some comparisons, and we'll go ahead and call it a night. Diagnose motion in weather forecasting, in my opinion. You know, having all these parameters is great. Finding where things are co-located at the same place at the same time is great. But one of the keys is being able to properly diagnose vertical motion, or lift atmosphere. That's what's going to generate air mass. You've got high relative humidity. Vertical motion is going to lead to cloud development and precip. You're not going to get, as I mentioned with the Cape, you've got, you could have 5,000 joules per kilogram of convective availability. If you don't have anything to lift it, then it's just going to stay potential energy. You've got to have something to make it kinetic energy. One of the things I wanted to show you is one of my favorite tools for diagnosing vertical motion. One of the long-standing ones is a product called absolute vorticity. There's absolute vorticity, there's relative vorticity. They're similar, but absolute vorticity includes the Coriolis force of the Earth, and relative vorticity doesn't. So basically, you use absolute vorticity in the mid and upper levels, relative vorticity closer to the surface where the Coriolis force is less of an impact. But that's been a long-standing tool for, you can use it to assume vertical motion. So vorticity is just the spin of a parcel of air, and it considers shear and curvature. And you can, considering a number of assumptions, you can infer vertical motion downstream from your vorticity maximum, and you can assume sinking motion upstream, so back behind it. And a lot of times that will work, but there are cases where the vorticity can be negated. Sometimes it can be what's called a shear lobe, where it looks like you've got a vorticity maximum, but if it doesn't cross your height contours, if it runs parallel to them, it's going to be pretty much shear. It's going to be shear dominant, and that means that even though it's showing up as strong vorticity, it's going to generate weak ascent. It's an advection jet. You see them a lot of times with jet streaks. So you can get vorticity maximum that runs perpendicular to your height contours. That's going to generate a little bit stronger ascent, assuming it's not negated somehow. But anyway, digress. One of my favorite tools for diagnosing here is called, and breaking these down is a little bit beyond the scope of this video, but basically it has to do with quasi-geostrophic theory, QG theory, and the one is you've got Q vector convergence on the downstream side of it, in this case the trough, and then you've got divergence to the upstream side of the trough. So where you've got Q vector convergence, you tend to see ascent. You can assume there's ascent. And where there's divergence, you get sinking motion or subsidence. So I just want to show you kind of how the Q vectors did today. I'll point out on the they actually map it out with Q vector divergence. So the convergence is actually going to be negative terms. It flipped. But they've got it color table. It's coordinated. it's the more you can infer ascent. Now you have to assess this with a few other properties, but this is my favorite tool to assess vertical motion because thermal advection has a lot to do with ascent and descent in the atmosphere. So shear and curvature has a lot to do with ascent, your vorticity, and then thermal advection has a lot to do with it. Q vectors don't just consider the shear and curvature like your vorticity products do, but Q vectors also have a term for thermal advection, so they consider them both. And if we just run this back through today, the heaviest rain showers today, there wasn't anything severe, nothing like that, but the heaviest rain showers occurred across Indiana today. And as we Q vectors through the past few hours, you can see the strongest Q vector convergence was across Indiana, dead on with where the heaviest rain was. And then there was moderate Q vector convergence across Kentucky, where we did have some moderate rain showers. And you see your wind vectors, where they point into each other, that's convergence. The longer the vector is, the stronger the going to see it correlate with your value, and the stronger you can, if you apply it to some other parameters, the stronger you can assume the ascent might be. But a pretty good job today of what the heaviest rainfall was. So that was just something to point out. So now, we'll look at a couple things and wrap this up. One thing I really want to look at here is something that's very, very important to consider in any forecasting scenario, not just something where it's a lot of things going on over the next few days, but model differences. You want to see where the models have, where they don't, all of the stuff, all the little things they have with each other. Because it's important, sometimes you've got to be able to pick the right model, and you got to be able to discount. And it's, I'm not a model hater, but I always advocate doing the analysis first. Have a general forecast in your mind, some sort of prognosis for what to anticipate before you look at the models. But the reality is that there's no way I could solve the problems that the models solve. They're critical. So this is just the GFS and the Euro, two of the models that we've been seeing all over the internet. They're two of the more popular models in the world, and they're all over the place right now with all these quote-unquote snowstorms that are being forecasted. So we'll just run it out. This is 500 millibars, wind vectors, and vorticity. So this is 12Z Saturday. It's valid for 12Z Saturday, and you see they're fairly close with each other at this point. This is 48 hours out from the model run. You see you've got the trough swinging in just off of the coast of Canada, and we've got our cutoff low down here in Mexico just south of the U.S. And that's something that I'd said, I think that low and then the high pressure to the north of it's going to be really important in how things play out. So here we step another 24 hours out. This is Sunday, 12Z, Sunday morning. So now we see a little bit of model divergence. We've got, both models have the cutoff low developing in wave and then moving out into the central U.S. The GFS is a little stronger with it. The Euro flattens it out a little bit quicker. But the Euro is more, it's a little bit more progressive and faster with this trough coming in off the Pacific Northwest coast. We step another day out, and now you can see it's much more progressive with this trough coming across the central U.S. It's got it almost into Nebraska. The GFS still has it clear back, really stretched back into California. So quite a big difference between the models already at that point. Along the eastern U.S., it's not too far off. It's pretty uniform with height rises, ridging building in advance of the coming trough, but the timing and amplitude of the trough between the GFS and Euro are still a little bit off. Now, I will point this out. These models have been coming together. So, they're a lot closer now than they were, say, 24 hours ago. And at this point, we'll go 5 days out. You can see a lot of a difference where the GFS really has it intensifying but hanging back to the west. And this kind of begins to eject as more of a separate short wave pivoting around a longer wave, while the Euro maintains a cutoff low off the coast of California with this high pressure along the Pacific Northwest coast. It's a little bit more broad with its deeper low across the northern U.S. Good. 2 more things I want to show you real quick. This is just a simple spaghetti plot. I want to show you that it gets even more complicated than that. And what I'm trying to instill is simply, think about things. When you see these things online, think about them. If it doesn't seem like it makes any sense, maybe it doesn't. And understand that these things are really finicky. And I don't care how much we know. The fact is, sometimes these things just don't go right. So, expect the cold, but maybe don't put too much weight. Don't go buy all the milk and bread for a snowstorm in 3 weeks. That's all I'm saying. So this is a spaghetti plot. It just maps out different contours. This is 500 millibar heights. Pretty much the same thing we just looked at, but each responds with each line of a certain height contour for model. And what we're going to do is see how quickly all diverge from each other. So here we go, 24 hours. Still relatively in with these. Step out. We'll just go out. Why not go out 96 hours? Just about 3 days, a little over. And now you can see pretty good model divergence. Some of the models have the mid-level low or the mid-level trough off the coast of California. Some have it across the Central Plains. Some have ridging across the eastern U.S. with a really sharp trough coming off the East Coast. Some just have it relatively flat and zonal. Some think that on the Euro. I'm going to wrap this up. I want to keep this about 45 minutes. So I'll show a quick loop. I want to show you how long it took the Euro to accurately prognose or accurately depict and simulate the current observations. Because these things run out a long time. I mean, we just looked at the GFS out to 240 hours plus. Alright, what we're looking at here is 500 millibar heights at the time of this particular observation. So it'd be 12Z today, 500 millibar heights. The red contours are respective model runs of the European model. So the red contours at this step are the Euro model from the 23rd 12Z run. So this is 168 hours from today, before today. And you can see not very close at all. Off with the position of thing, much too sharp with the trough moving through the mid. Height rises way higher than they really were off to the west. Cutoff low, just not quite in the right place at all. Completely the troughing out in the Atlantic. That short wave that passed across Florida here in the previous couple days. So not too close. We go out 100. This is 144 hours out. So this was the 24th. A little bit better, but now it's it's way up with the amplitude of the cutoff low out in the Pacific. Position and intensity or sharpness of this trough across the Midwest is still off. It's a little bit closer. But then we go 120 hours out. This is the 25th. And it's thinking the trough's going to be back across the Central Plains again. It doesn't quite know there. Instead of the height rises out ahead of it, the flow flattened out. It completely missed this trough here and had it shot way off to the northeast. So now 96 hours, this is the 26th. Now it's starting to come into focus a little bit. It's still not dead on, but you could work with this. It's got the Great Lakes pretty close. close. If you'd forecasted that, you'd pretty much verify. This cutoff low out here, it's relatively close to where it needs to be, and it even hits this trough up here a little bit. So that's 96 hours out before it really gets to any point. It hones in on it a little bit more, and then this was just 24 hours out. This was 12Z yesterday, and it pretty much nailed it. So it took it till about 96 hours out from the event to really hone in on what it was looking at. And the last thing before we cut this video, just so you don't think I'm picking on the European, I got the GFS for you too. Alright. So similar deal. Blue is observations, and red is the respective model run. So this is going to be 06 was the observations. This was a little bit. This was 6 hours before the previous one, but blue observations, red is the respective model run. So 144 hours out. This was the 24th. You can see really had a much long wave pattern across the central U.S. as opposed to the sharper trough moving through the Great Lakes. Not terrible, but it completely flattened out the flow into the up past New England really flattened out that flow, when really it's a trough moving through there. Tonal flow coming in across the west coast. Significant height rises instead and had been building. Now it's a whole nother picture. This was the 20 hours out. It's got a short wave moving in the western U.S. It's got the cutoff low. Not perfect, but it's out there. I don't know what this is. I guess that's a short wave. It's supposed to be moving through the Dixie Alley, and then it's basically got out zonal flow north of the Great Lakes, and a sharp trough in northern, not in the spot it's supposed to be at all. So really not close there at all. We'll go 108 hours out, getting a little closer. It's starting to pick up on. It's bringing the heights in western Canada, the western U.S. down a little bit, and it's starting to bring this trough to a little bit closer to reality there. Again, it's still got this short wave here. It's a little bit sharper than it actually was, and it looks like it was attempting to get the short wave that moved off to Florida over the past couple of days. 96 hours out. Now it's got this trough that moved through way off to the west of where it actually was. Still doesn't know what to do with this short valley area. Still has no idea what to do with it. It's getting a little closer to the Pacific, but again, not really right on. I mean, it doesn't matter if the troughing across the U.S. is 500 miles too far west. And then it starts to close in a little bit, 84 hours out, 72 hours out. It starts to hit this right on the head. It's just a little bit off across the northern U.S., but it's getting, much closer. That's a whole lot better. And then, so 72 hours out before it really gets close. And then 60 hours, it starts to hit it right on for the most part. And 48, so on and so forth. It really starts to tighten in. So, I mean, really 72 hours before the GFS was close and 96 hours before the Euro was close. So, the point of that before I say goodbye is think about it. It was 72 hours before the GFS started to get close with today's pattern, which isn't what forward. What we're looking at is going to be more complicated. It was hours before the GFS really even got close to what we're looking at today, and it was 96 hours before the Euro got it. So, they're not going to do that every time. Sometimes it's going to be better, sometimes it'll be worse. But just consider that. See a forecast model graphic online for 20 inches of snow across the entire U.S. and consider that. Guys, it's been awesome. I enjoyed doing this a great deal. Next week we're going to talk about... Oh, perfect timing. Next week we're going to talk about winter weather forecasting. Right on cue. We'll talk about winter weather forecasting, and we'll even break down some soundings, talk about forecasting precipitation types. So I hope you guys really enjoyed this. Like I said, I enjoyed doing it for you. And see if we got anything else. Like everything. Love you guys. Stay cool.